Hello everyone, welcome back to Spectrum Classes. So in this video I am going to solve few numerical problems based on zeolite water softening method. And here is the first numerical problem, and while we are solving this first numerical problem, I will tell you each and every single term which we are going to use and why we are going to use that. Once we are going to solve this numerical, we will be able to understand the basic terminology, and in the next numerical problems we will directly apply the formula. And different type of numericals I am going to solve here based on this zeolite water softening method. So I hope you will be able to understand after going through this video how to solve these numerical problems with detailed explanation or with simply tips and tricks, right? So I'll start without delaying. So here is the numerical problem. The hardness of 50,000 liters of a sample was removed by passing it through a zeolite softener. Suppose I am having a zeolite softener like this. It is just a small representation, right? The softener then requires 200 liters of NaCl solution containing 125 grams per liter of NaCl for regeneration. Calculate the hardness of the sample of water. So what do you understand out of this numerical problem and this statement? What it says? First it says we are having a zeolite softener, right? We are having water sample which is equal to 50,000 liters. This water sample is containing calcium 2 plus as well as magnesium 2 plus ion. You just see the animation. This calcium and magnesium having bigger size than the pore size of the zeolite, it is stuck over here. And now the sodium atom which is present on this zeolite bed, that goes into the solution. Fine. From the statement what we get? 50,000 liters of hard water, and once this is choked with this calcium and magnesium which is present in the hard water, sodium chloride which is required to regenerate these pores again. Here it means like that. First you understand we are having this much liters of hard water, and once this is passed through this zeolite bed, this zeolite bed is exhausted, and which requires 125 grams per liter solution of sodium chloride or brine water and 200 liters of sodium chloride solution. First I will tell you, we are using this normality equation, N1V1 is equal to N2V2. I will tell you what is called normality. So normality is number of gram equivalents per liter. Now you may have a question, what is called gram equivalent? Because many of my students always find it difficult to understand this gram equivalents, equivalent weight, molecular weight. They find it difficult. So I will here explain one by one. So what is called gram equivalence? So gram equivalence is equal to weight divided by equivalent weight. So this is equivalent weight. Please keep this in your mind. This is equivalent weight, and when weight taken is divided by equivalent weight, that is called gram equivalent. Fine. Now the next question is equivalent weight. What is called equivalent weight? So equivalent weight is equal to molecular weight of any given salt divided by n factor. This I have already explained in one of my video. I will give the link of that video in the description box. So what is called n factor now? So n factor here in this case, n factor is valency of cation. So what is cation? Sodium is cation and its valency is +1. So +1. Molecular weight of NaCl is equal to weight of sodium 23, chlorine 35.5 grams of atomic weight. So when we add these together, we will get the molecular weight of NaCl. So this is equal to 58.5 grams per mole. Unit of this is grams per mole, right? Or in another words, you can say 1 mole of NaCl. 1 mole of NaCl is equal to 58.5 grams. Important point here is how we are going to calculate the equivalent weight for sodium chloride. So what I said, molecular weight. So molecular weight is 58.5 grams divided by n factor. So here what is the n factor? So plus 1. Here we will drop the plus minus signs. We will take only the number. So 1. So 58.5 divided by 1 is equal to 58.5 again. Now this is the equivalent weight. So we will put this equivalent weight here in this equation. Okay. I'll show you here. You just see. Gram equivalent is equal to weight upon equivalent weight. So just write down. Normality of NaCl we are going to calculate for NaCl, which is given here 125 grams per liter. This is the weight taken. So weight we will put it over here, and then I'll just write it gram equivalents 125 of NaCl in grams divided by 58.5 grams per equivalent. Here you will see. So this is equal to gram equivalents. And now going to calculate the normality, because we come to know the gram equivalent, so its normality will be equal to the same. So normality is equal to 125 divided by 28.5 gram equivalents per liter. This is the normality. In case of hard water, we have one condition, that we have to calculate the hardness or alkalinity at calcium carbonate scale. So here again we have to do the same exercise. So normality of NaCl at calcium carbonate scale. So what we need to do? We need to multiply this by 50 gram equivalents of CaCO3 per liter. So what is this 50 gram equivalents of CaCO3? So CaCO3 is 100 grams per mole. And here valency of cation is plus 2. 100 divided by 2 will be equal to 50 gram equivalent. This is the equivalent weight of CaCO3. So the factor which we get over here, we will multiply it by 50 grams equivalent weight of CaCO3. Then we will have the normality of NaCl at CaCO3 scale. You just see NaCl at CaCO3 scale. What you need to do? The weight which is given in the numerical, this is 125 grams, divided by weight of NaCl into 50 grams of CaCO3. So in every of the numerical, if it is required, then you have to multiply it by this factor 50 divided by 58.5. The values of N1, V1 and N2, V2 in this normality equation. What you have? Hard water volume, NaCl volume. And what about the normality of NaCl? So normality of NaCl at calcium carbonate scale is this much weight multiplied by 50. This is the calcium carbonate equivalent weight, and the whole factor divided by 58.5, which is the equivalent weight of NaCl. So 58.5 grams. So this is the normality value of NaCl. So normality of NaCl is known to us now. Volume of NaCl is known to us now. Volume of hard water is known to us, and we will put all these values here in this equation. So N1 for hard water multiply by 50,000 the volume given for hard water which is passed through this zeolite bed is equal to N2 normality of NaCl. So what is that? 125. This is the grams multiplied by 50 equivalent weight divided by 58.5 equivalent weight of NaCl into 200 is the volume which is given for NaCl. So from this equation we can calculate the N1 or the normality, right? So this factor you always need to remember from where it comes. Okay, so normality for hard water, after calculation we will get this. So this is in grams, and if we convert this into milligrams, so 10 raised to the power 3 milligrams equivalent per liter, and this is also known as ppm, parts per million. Milligram equivalent per liters is equal to parts per million. So this is the hardness of the water which is passed through this zeolite bed. Fine. So this is the answer. The next numerical problem is the hardness of 10,000 liters of sample of water was completely removed by zeolite softener. The zeolite softener required 60 liters of NaCl solution containing 1.5 kilogram per liter of NaCl. Calculate the hardness of water solution, right? So here is the normality equation. We will one by one put all the values in this. So for hard water, 10,000 liters is given. Normality is asked From here you can understand. And now we need to calculate the normality of NaCl at calcium carbonate scale. So how we are going to put the values? Here you just see 1.5 kilograms we have taken over here per liters. Now we will convert this kilograms into grams. So we need to multiply it by 1000. Here you see the units gram per kilogram. So per kilogram we are having 1000 grams into 50. So from where this 50 comes, this is equivalent weight of calcium carbonate, because we need to convert NaCl normality on calcium carbonate scale. This is whole factor divided by 58.5. So what is this 58.5? This is the equivalent weight of NaCl. Now we will cancel out the units which are applicable. So kilogram on numerator, it is divided by this kilogram which is on denominator. And now equivalent weight divided by this equivalent weight. Okay. This liter will be cancelled out by this liter. So here is the normality of hard water will be equal to, we will solve this and we will get the answer. So normality is this much gram equivalents per liter, or we can convert this into milligrams, since milligram equivalents per liter is equal to the parts per million. So to convert it in ppm, we multiply it by 1000 milligrams to convert this gram into milligram. So this is the answer. The next numerical problem is here. An exhausted zeolite softener was regenerated by passing 150 liters of NaCl solution, having a strength of 150 grams per liter of NaCl. If the hardness of water is 600 ppm, calculate the total volume of the water that is softened by this softener. So here, what is different from other two numericals? Here, hardness is given and volume is asked for hard water. So we simply apply this. Now put all the values which are known to us. So 6. So here, hardness of water or normality of hard water. This is in ppm. ppm means milligram equivalent per liters. And hardness is given at calcium carbonate scale, right? Into volume V1. So V1 is asked to us. Now we are coming to this NaCl. So NaCl, for NaCl 150 grams is given. So 150 grams will be converted into milligrams since it is in milligrams. So milligrams per grams. So in 1 gram we are having 1000 milligrams. Okay. So this is 150 grams of NaCl. This is converted to milligrams into this 50 gram equivalents for calcium carbonate. And here it is 58.5 is for equivalent weight of NaCl. This is by mistake molecular weight, but it is equivalent weight of NaCl since both are same. Molecular weight divided by 1 is the equivalent weight. Okay, and multiplied by its volume. Volume is given here 150 liters of NaCl. Now we will cancel out the units. So gram will be cancelled out by this grams. Gram equivalents will be cancelled out by this gram equivalents. Here we are having milligrams per liter. Here we are having milligrams per liter. So this will be cancelled out because this is on the left hand side, this is on the right hand side. And when it divides this, that will be cancelled out. Now the volume we are going to calculate after solving this equation. We will get this much liters of hard water. This is the answer. Hard water. The next numerical problem is a zeolite softener was 90% exhausted when 10,000 liters of hard water was passed through it. The softener required 200 liters of NaCl solution of strength 50 grams per liter NaCl solution. What is the hardness of water? So we will put one by one. Here N1V1 is equal to N2V2. What is known to you? Liters of water is known to us. Liters of NaCl is known to us. And strength of NaCl solution is known to us. So we will convert it into normality at calcium carbonate scale. So what need to do? I'll just put all the values here and then one by one you will be able to understand. This is 50 grams. So here 50. Converted this into milligrams. So multiply by 1000. Okay. This is 50. It comes from calcium carbonate. And this 58.5 comes from NaCl. This is the volume. Volume is 200 liters. And here is the hard water. Now N1 we are going to calculate. These are their units. We cancelled out them. And here is the normality in milligrams per liter. So this is the parts per million is the answer for this question. I hope you understand. Thanks for watching. Thank you all.